Okay, ladies and gentlemen, let the show on the road on the heading. Any comments, questions, issues? Yes? Sure. Okay, so the question is, what about the sorted function? Let me get some code over here. All right. Whoops. So, suppose we have a list. Okay, so here's a list of numbers. And we can print the list. And if we say, we call the sort method on the list, that sorts the list in place. So that should give us the list in order. So there's the list original, there's the list in order. That's what we expect. So the sort method changes the list itself in place. Now, if I were to use the sorted method, that gives us back a copy of the list sorted. Let's see here. Okay, so the difference between sort and sorted is that sort sorts the object in place, and sorted gives us a sorted copy but doesn't touch the original object. So, what did I get here? List object has no attribute. What's the syntax? Is it sorted? No, that. Yeah. Okay, so sorted is a function and not a method call. All right, so here's the original list before we do anything to it. Here is L in order, but here's the original list L again untouched. So this is something we'll get to in a little more detail a week from today. Sort of put off a conversation about mutable and immutable and what gets changed where in memory because it's a little so. There'll be a more thorough discussion. But basically, sometimes you want to take your object and do something to it. Sometimes you want to get a result from the object, like a copy of the thing in order, but you don't want to change the original object, you want to leave it alone. And for sorting, Python gives us two alternatives. The sort method that changes the thing in place, and the sorted function that gives you a copy of the thing in order, but doesn't change the original list. So, other comments? Yeah.
So that's why we can do that with name tuple, and like because I remember tutor telling me that it was immutable.
Well, yes. So again, that we'll get to in detail next time. But name tuples indeed are. Let's put it another way. Like that. And name tuples are immutable. To change, you have to make a copy. So if you want to change a name tuple, Suppose that we have a name tuple of something called B. We cannot say B dot sort okay. Right, we can't say B dot sort. We can say, well, B actually, we can't say B dot sort because B is a name tuple. We don't want to sort it. If we had a list, okay, we can't say B. Okay, so doesn't make sense to sort a single name tuple. Does make sense to sort a list, which we can do. You know, a list of numbers, a list of name tuples, a list of whatever, doesn't matter. We can change a piece of the list, leaving the rest of the list intact, because lists are mutable. We can't do this, which I'm sure is something everybody ran into in the lab. We can't just say assign to the size field of a name tuple. That's what we can't do because name tuples are immutable. We can't take the existing name tuple and pop a new value right inside. But what we can do is reassign B to a new named tuple with all the old values except what we want to change, and we can do that with underscore update, or we can do that with the constructor of, if B is book, this would be book, right? I just didn't go through the whole example here. But we can create a new B with all the original values, field 1 of B, field 2 of B, and the size gets the new value. That's okay. That's the second way of creating a new B, of changing B to have a new size value. Okay, so that's the sort of synopsis of that. Other questions? Yes. Oh, hang on, sorry. Yes.
So all objects are immutable.
Not true. I don't think that's true. That's everything's an object. As far as we're using the term object, everything's an object. So we're not doing class definitions, which is sort of the official term object definition. So what's mutable and what's not mutable. Lists are mutable, strings and name tuples are not mutable. And that's pretty much all the multiple value things that you There is, if you remember, on the resources sheet, there's on the resources page, there's a link to a sheet that summarizes all the data structures, and there's a table there, and that gives you a column of what's mutable.
So for pre-increments and pre-decrements, is it possible to use operators other than addition?
For pre-increments and pre-decrements,
Yeah.
so you're thinking about C?
Or does a repetition statement on the notes, there was a list, and we did list index is equal to list index plus 1.
Okay.
I was wondering if you can use another operator other than addition.
Yeah, you can do anything you want to, if you want to go through a list, right? So if we want to go through the list and change the items in the list, we can say L sub I equals, we can do whatever we want, right? L sub, give it any value we want. Okay, so go through the item, right? Since we're assigning to a value, we want this to be a number and not just each item in the list. So that's why we use range here. So we have the index number that we can use because we're assigning to a particular index. So we're saying for each index, take its previous value, multiply it by 100, and assign it back. And that's what we got over here. Okay. Other comments or questions so far? Yes.
Sometimes when I'm implementing a function, it ends with return. Why does it do that?
Okay, so there are functions that return values, like use a chocolate ice cream stand on page 23, and it comes back with a bowl full of icing, or like double that takes a number and returns twice that number. Most of the time, most of the functions we write will be functions that return values. But there are some functions that don't return values, that have some side effect, like printing, that's the most common, like drawing on a canvas, or like, those are probably the most common things that we've seen. And so those functions don't return anything. They just do what they do. They print, they have their effect on the real world. And so the return statement says return, not return something. And when we annotate that in the function header line, we say, def function name, parameter list, arrow none, or we can leave the arrow none off, right? You can just have the parameter list and a colon and not have a return value. That would be okay too. Other comments or questions? Okay, great. Let's see here. Let me capture this. Did I just do what I wanted to do? No. Okay, so I'm going to put these notes down at the bottom of our program and comment them out. All right, so if you remember from last time as we left off, we were writing this restaurants program, which starts with an empty collection of restaurants and lets the user add restaurants and then search for them and remove them and print the collection. And then, right? And so we got, you can remember what it is that the program does. Prints out a menu, add a restaurant, Okay, so there's a restaurant. We add it. We can print the restaurants in the collection. We can search the collection for restaurants. Maybe there are no restaurants. Maybe there is a restaurant. Right, so there we get it. We can remove the restaurant from the collection. Now we print the collection, there's nothing there, and we quit. Right, we have a little error message if we get the wrong kind of command. We saw that before. Okay, so that's what the finished version 1.0 of this program is going to do. That's what we're going to be an hour from now. Questions about what this program is doing, what our goal is. Okay, so we left off with a program that does some of this. We can add a restaurant, and it just says add a restaurant. And so we've left the kind of real work as program stubs, S-T-U-B-S. That's a technique. Since you can't write all the code at once, right? It's a terrible strategy to write 2 pages of code and type them in, and only then hit run. Because if something's wrong, you have 2 pages of code to look for it to figure things out. Instead, we do as we've been doing here in class. We develop incrementally, a function at a time, and we test the function to see if it works, and then we implement the next one. And so to do that, sometimes we need to write a function header or have a placeholder because we can't write out the entire full final functionality for everything all at once. That's what I just said is a terrible idea. So we have to leave a sort of a placeholder that will replace with the real action later on, and that's what we've done here for each of the restaurant commands here. So remove just says we're going to remove, search says we're going to search, print says we're going to print, quit quits. Other commands, I think we did the error message, and so that's where we left off. So here was our main program, which we called at the bottom, right? We called the program called restaurants. Restaurants printed out the welcome message. At the end, it prints out the thank you message. There it is. And meanwhile, it starts out our list of restaurants with an empty list, and then calls handle commands on that list. And handle commands, as we'll see in a minute, repeats printing out the menu, getting a command, doing the command, and so on, changing the list of restaurants, the collection of restaurants. And then handle commands at the end returns the modified collection, which we save, and then we go away. In version 2.0 or some later version, we'll write it out to a file so we can save it from one time to the next. That's kind of useful. But for today, that's not part of version 1.0 of our program. Okay, so we have our menu. We have our handle commands function, which that was the first version here. The second version takes that list of restaurants and prints the menu, gets the user's response, calls that command, and then looks at the command. Is it Q? Is it A? Is it R? Is it S? Is it P? Right? If it's Q, we're done with the loop, and we go back to return the collection, however we've modified it. And if it's not Q, then if it's one of the commands, we do what we're going to do. Otherwise, here's the error message. And that's where we left off. Okay? So comments or questions about any of that? All right. So let's start by building part of the model. Let's start by building the restaurant. And so that's going to be a name tuple, of course. All right, so there are 5 fields: the name, the kind of food served, the phone number, the name of the best dish, and the price of that dish. Okay, so what we what we're probably going to want to do is construct a couple of restaurants just to use in our testing. You know, it's always a good idea, right? If you have a program of any size, we're going to want to write assert statements, since this whole program is an interactive program instead of just a collection of functions that work at the command prompt. It's going to be useful for us to build up our own data in the program, in the text of the program, just to use in testing. So why don't we just do that? Okay. Let's have one more. Okay, so I have 3 restaurants, and let's have a list of restaurants. 1, 2, 3. What will we use for 10? Okay. It didn't take us very long to do that. I mean, it sort of seems like it's sometimes why we're doing this after somebody's back. But it took us how to do it. It's worth the time. To make up a couple of realistic tests, so that test data cases, so that you'll have them to use when you write your assertions and make everything work. So, let's build. I mean, we know that we have something that makes restaurants. We just get that with the restaurant name tuple automatically, and we know that we can get the fields of a particular restaurant, so that R1.name is Thai Avant and R2.cuisine is Thai. But we're going to need 2 more. We're going to need 2 more functions. One is a function that prompts the user for the information about a restaurant. So we saw that in the old. Actually, maybe it's here. No. Okay, so we don't have the execution anymore. But we saw when we ran the real program, enter the restaurant's name, enter the restaurant's kind of food served, enter the restaurant's this, enter the restaurant's that, enter the restaurant's other. And so we prompt the user for those, and then we need to create a restaurant out of that. So let's do that, and let's call that where are we here? Restaurant get info. Okay, so restaurant get info is going to take no arguments because it's going to get its input from the user at the console. We're going to say, please enter the name, and the user is going to give us the name. So we don't pass anything in, but we return a restaurant. And Okay, so we're going to prompt the user for the fields one by one, create them and return. So here's the sort of most simple way to do that. Get my apostrophes right. Okay, so we're going to say, please enter the restaurant's name. The user's going to type something. We're going to call that N. And please enter the kind sir. We'll call that C. And please enter the phone number. And oops. Okay, so 5 prompts for the 5 fields, column NC, PH, D, and P, and then we just want to return a restaurant made out of those 3 fields, or those 5 fields. Okay, so there we go. We can't do an assertion because this is interactive input. Okay, so let's run this, see what happens. Well, we're not going to be able to do that quite yet unless we call the function. So tell you what, for right now, let's just call it once. Okay, so here's our function. We're just going to call it once. It's going to do these things, and then it's going to print the constructed restaurant. So let's see what happens. Yes? Well, print is predefined, so there's no problem there. Restaurant get info, we defined above, so there's no problem there. If we want to call it up above, I think we're going to find this is going to be okay because we're not going to execute that. Right? Python is going to read all the code and doesn't start executing until the bottom. And that's why we have the call to restaurants at the end. We don't start executing until we have all the definitions. And then this will go back and call the main program, which we'll call handle commands, which we'll call restaurant get info. So by the time we get to here, everything will be defined, and so we'll be cool. If we had that call up at the top here, then we'd be in trouble because it would start doing the things before the definition. Good. Other. There's a question. Okay, so anybody see? Well, let's see what happens. Okay, so we're just calling this thing one time. So please enter the restaurant's name. Okay. Okay, so we have those pieces now. You know, there's always a temptation to fine tune the output, the way things look, and you know that's a good idea. And we'll go back and we'll add a couple of spaces after the colon here so that it looks a little bit nicer. In writing real code, you have to be a little careful not to have all your time taken up by polishing the output to make it look just perfect. You know, if you're writing a professional product, then part of the job. If you're writing something for a class, unless the precise formatting is part of the exercise, it's possible to spend all your time on that, which isn't bad per se, but it's usually not the main point of the exercise. So, there's the temptation to fiddle with the look of things more than we do. So, we have the 5 values for the 5 fields, and it prints out the restaurant. Name is McDonald's, cuisine is burgers, phone is blah, 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 right? So here's our restaurant name tuple, our restaurant object that we just created, right, with the 5 fields. And then it went on to the bottom and saw the call to the restaurants program and started the restaurants program. So that's why we have the menu, which is okay. We don't care about that. So, comments or questions about this code so far? All right, so let's put in a couple of spaces just to make it look a little nicer. All right, so what this gives us is a restaurant object, which is exactly what we want. It's what it's supposed to return. And there we go. Now, it would have been possible to code this, all sort of in one statement. Return, parenthesis, call to input with the asking for the name, call to input asking for the cuisine, call for, you have all 5 calls inside the, inside the restaurant constructor, inside the return statement. But, we don't have to. Okay, so we know how to get a restaurant in. For our users, we're not going to print restaurants in this form. This is nice for Python programmers. It's not nice for normal people. And so we need to print, we need to produce our restaurant in a human-readable way. And that's another function. So we did this test. We're going to comment that test out now. And now we want to have something that prints the restaurant in the way that we've seen. I don't think I have an example, but name colon name of the restaurant, cuisine colon type of cuisine, and so on. So what we're going to do is write this as a function that takes a restaurant and returns a string. And the string is going to be a 5-line string, name colon whatever, cuisine colon whatever, phone colon whatever, dish colon whatever, place colon whatever. And that 5-line string is what we're going to return, because that's going to be the printed representation of the restaurant, at least for now. So okay, so we can do this in one statement easily enough. So we want to have the first line be name and the name of the restaurant. And remember, we're returning one big string. So we're just concatenating. We use the plus operator to stick strings together to concatenate. We're concatenating all the little components together to make one big string. So let's add the new line. Oops. Okay, so And this should do it. So an extra empty line at the end. Okay, so we can have an assert statement for this one. So if we take R1 and make the string out of that, we should get now I've got to get the, I mean, this is the worst part. I've got to get the number of spaces right. Actually, do it this way. Forgot it. And I think this is going to do it. So let's try this. We're going to need to, actually this will work. Now, the tricky thing with these strings is to make sure that we have the new lines in the right places and the right number of new lines and so on. So I guess I'm going to help myself a little bit. We did this sep equals before, right? Yeah. So remember that this just says don't put any blanks between the items you're printing out. So to help us in case the in case our assertion fails, it's going to fail because we've got the spacing a little bit wrong. I counted my spaces wrong, or I didn't put in enough new lines, or something like that. So I'm going to have this for reference. I'm going to have this for reference with an apostrophe, and then we'll see exactly what's what in case it doesn't work. So, because I'm not inside a set of parentheses, I need a new line or a backslash to escape the new line. So that's okay. And now, what do we have here? Okay, very good. Actually, why is it a float object? Did I make it a float object? All right, so here's my error. It's a type error. It says can't convert float object to string implicitly. And so oh yeah, of course. So in R1, I entered this as a number, so it thinks it's a float object. It is a float object. It's a number and not a string. And so when I'm trying to take that value and stick it into a string, it says, wait, this isn't a string. I can't do that. So I convert it to a string. And that might just remind us that when I input the price in the first place, I get a string, and I really need a float. So I have to do this conversion too. If we haven't run into this yet, because we haven't done any arithmetic with the price. The only reason we ran into the problem is I actually typed the number in my test. If we hadn't had the test, it would have taken us longer to to realize, to remember that we typed in a string, whatever the price was, and we needed to convert that to a number, same way as we've seen a bunch of times. You know, the user types something and it's meant to be digits, but we have to call int on it or float on it to make it stored as a number, and that's what we're doing here. So restaurant get info, we have to turn that into a float, so now we know we're going to have a number, and now we turn the price back into a string to create the whole string in the first place, which is also what we want. And so now let's see what happens. Okay, so we have an assertion error. Let's see what we have. So here's what we think it should look like, and here's what we actually have. It seems as though there's an extra new line here, right, which we intended. Right, we had an extra new line, so when we print a bunch of restaurants, there'll automatically be a blank line between each block for each piece of the restaurant. So let's see. Then the other thing that we're going to have to deal with at the moment is the formatting of the number. Okay, so again, the assertion doesn't pass because what we say it should look like doesn't quite match the reality. But the only difference, I think, at this point is that we don't know how to format the number properly. So we can deal with this right now one of two ways. Right? First way is we can fiddle with the test so that it matches the way the number comes out. Second way is I can put in the formatting code that you don't know yet to make the number come out with 2 digits and write a decimal point, and we just have to live with this code that we have explained until we just keep it out and explain it. So how many people want to see the unexplained code to make the output look nice now? How many people would rather keep that knowledge away and just change the test so that it says 45.0? Okay, fair enough. I mean, you know, different people learn different ways. It doesn't really matter. But here's how we actually have to do it. We have to say, and I'm not going to explain the intricacies of this right now. That's going to do it. So I have this this thing here that says 2 digits to the right of the decimal point, and I have the call to the format method that takes the thing I'm going to format according to that and substitutes it in here. And so now let's see what we have. Ha ha ha! We win. So no assertions, no errors, no headaches. Right, this part is just because we call to the restaurants program at the bottom. But here is our printed version of what the restaurant should look like. And there's no assertion error, which means that we, the version we get when we call restaurant to string matches what we said it should. So I'm going to keep the assert statement. I'm going to comment out this print statement. And now we're pretty convinced that we can read in the 5 fields and create a restaurant, and we can write out the restaurant in a reasonable looking way. So I think we're done with what we need to do for restaurants. Any questions about that? So we built the restaurants and a couple of special functions we use to handle restaurants. Now it's time to deal with the collection of restaurants. I got rid of the assertion error. Well, I think the last assertion error I got, was because I needed to format the number with 2 digits to the right of the decimal point. And before I just changed the code, it was printing it out the normal way with one digit value. And so I added that formatting code that we'll explain in a couple weeks, but not today. And that made the price look like a normal dollar. Odd. Question for there. The format method takes care of that. And so the same thing that stir does, the format method does, and it converts it into a string of a certain form, like people just sort of write an investment form, and that's what all that method does. The only reason not to is not really take up a significant amount of space. And once you build your tests as assertions anyway, if you have tests where you're printing stuff out and moving stuff in that's not part of the final execution program, that stuff, eventually you have to get rid of so the program runs the way it's supposed to. But if you have assertions, you can leave those in the program because then as you change it later on, they're all still silently standing guard duty, letting you know if something you change breaks something that previously worked. So, yeah, you can leave those. They're not that long. Certainly there's no significant. Remember, we have gigabytes of memory in our computer. Right? So, a few hundred bytes that goes through electrons. Something to think about, but not every efficiency decision is not every efficiency decision is a decision worth making because there are multiple kinds of efficiency. We'll come back and talk about this one of these days. But there's machine efficiency, right? How much memory your program takes, how much memory your program takes up, or how much time your program takes to execute. But there's also human efficiency. Human efficiency in terms of the developer, the programmer, right? How error prone is it? How likely is it that it's going to introduce a bug that's going to take you hours to fix? And also end user efficiency, right? If your program is going to be used by a million users and every one of them is likely to make a mistake and have to do something over at least once, you've wasted a lot of people's time. And these days, it's the human efficiency that's typically more expensive than the machine efficiency. I mean, it's not quite that simple. There are times when you have to think about machine efficiency. Not so much in this case. Good. Other questions so far? Okay, let's keep going and let's implement our collection. Right, so we have a list here, and all right, so we're going to implement the collection as a list. That's the only data structure we know for implementing a collection of things. Well, I mean, we need a couple of aspects, a single object. So for a collection of the same kinds of things, the only data structure we know right now is a list. There are others, right? And before we're done together, we'll learn 2 or 3 more that have a little more special purpose, functions. But the list is how we're going to do it for now. And so, what do we need to do with this collection? We need to be able to create an empty collection. We need to be able to add a restaurant to the collection. We need to be able to search the collection and come up with the matching restaurants. We need to be able to remove a restaurant from the collection, given its name. And we need to have at least one function for each of the commands that we're doing. So let's try to do a couple of those right now. So So collection new is going to give us a new empty collection. I mean, anytime, pretty much anytime you have any data structure, you want to figure out how to create a new one, because somewhere in your program you might want a new collection, maybe just to hold all the matching restaurants from the search function, or maybe for something else. But you want a way to create a new collection, and so that takes no arguments, right? You don't need to know anything about creating a collection, but it returns a list of restaurants. It's going to be an empty list of restaurants. Okay, and so let's do what we're supposed to do. So collection new should be equal to the empty list. That's pretty much the only test there is. All this thing does is return the empty list. And so we can write this. It takes exactly one very simple line. Return the empty list. Okay. So now we can create a new collection anytime we want. Just an empty list, returns it. Here's our assertion. And I'm so confident it's going to be true that I'm not even going to test it until we do the next function. So let's do collection add. So collection add needs to take a list of restaurants and a restaurant. Okay, so we take the collection, we take the new restaurant to add, and what we should return is the new list of restaurants with the new restaurant added into it. And so, whoops. Okay, so that's what we're doing, right? Take the list of restaurants with the input or the argument restaurant added at the end. I'll just mention here, I think probably you've all gotten this resolved by now. One of the things about a relatively new field, right? Computer science about 70 years old, mathematics, for example, one of the things about a relatively new field is that it doesn't always have this terminology completely settled so that everybody agrees on exactly what it's going to use and how and when and where to use it. So in the last week doing the lab, the term input has come up in two different contexts. One context is the input function that prompts the user, and it's an input function, and it prompts the user and returns what the user types. But we've also talked about inputs to a function, which means the same as arguments to a function, parameters to a function, and doesn't have anything to do with calling Python input function. That's true of me, sorry, we'll come back in 200 years and we'll probably be well set. Right? I mean, there are good things about being in a new field, right? It's not hard to understand some of the frontier research questions, right? I mean, I promise you, if you go to a research talk in the math department, unless you have an extraordinary background, you're not going to understand a word of it. But the interesting research, you have to have an undergraduate degree in math and half of a graduate degree in math before you can finally understand what the mathematicians are working on. But they had 2,000 years to do it. Computer science, 70 years, and that's enough so that the research frontiers, looking here in ICS 90, right? I mean, you see that the research frontiers are at least understandable, right? I mean, maybe first year students are going to solve the research problem. But it's easy to understand what they are. So it's a good thing. Right? Another good thing about a new field is that often the growth is fast, right? And we're still in the Moore's Law realm where every 6 months, every 18 months, computers get twice as fast, give or take. That's also exciting. But, one of the costs is there's some unsettledness with the technology. Okay, so collection add takes the collection and a restaurant, and returns a list of restaurants with the new restaurant added to the end. And so, actually doing that is pretty easy. Append to the collection this restaurant, and then return the collection. So here we can say if we collection add to the new collection restaurant 1, that should be a list containing restaurant 1. Right? So here's an empty collection. Add a restaurant to that, we should have that restaurant in it. If I do collection add to the list with our R2 and R3 in it already, and add R1 to that, I should have the list R2, R3, R1, right? So the new one should be added at the end. Well, maybe that's good enough. We're adding to an empty list. We're adding to a new list. That's probably good enough. Okay. So there are our assertions. I should have written the assertions before I wrote the line of code, but it was just one line of code. And so now let's kind of go back. We have collection add, and we have restaurant get info. We can actually change the add a restaurant stub. We can change the add a restaurant stub to say something like this. Our collection is collection add, the current collection, and the information we get when we ask for a new restaurant. Okay? So call restaurant get info, right? That's the one that says please enter the name, please enter the cuisine, please enter the phone, please enter this, please enter the price. That returns a restaurant. So we can call collection add with the collection that we start with. That's the starts as the parameter of the function. So whatever we already have from the beginning, we add to that collection the restaurant we just created, and that gives us a new collection which we assign back to RC, so that when we repeat the loop and add a new restaurant, we can add a new restaurant. And as long as we're here, well, let's just leave it at that for the moment and see if we run into assertion problems. What we might do, the next command we might do is the print command, so we can see our list of restaurants as produced in the program. But now we can do the A command, and it should work, or it should give us an assertion error. So let's see what happens. Here's the program. A, restaurant's name. Okay, so I've gotten all the way through the loop. So I've called collection add, I've called restaurant get info. We saw restaurant get info. Right? We didn't see collection add, and I don't have the print statement implemented, so I can't see yet what's in the database from the menu. But I didn't get any assertion error. So I think we can reasonably be confident that our empty collection and our add to the collection functions work. Okay. So if we can add something to the collection, let's do what we just said we were going to do, and do the printing. Now, let's see if I want to do this here. Yeah. So we could have a collection print that takes the collection and calls the print function and prints things out, but we're not going to do it that way. Because of our resolve last time to separate the interface from the internal processing. So what we're going to do instead is the same approach that we did with the individual restaurants. We're just going to have a function that returns a string. Here we return a string for one restaurant. We're going to build something now that will return a string for the whole restaurant, and we'll return that to the calling program, which can then go ahead and print it out. So actually, let's just do that part here instead of calling this. We're just going to call print. Oops. All right, so take our collection in the handle commands program, right? In the handle commands program, we call our collection RC. And so take that, turn it into a string that represents the whole collection, which is just going to be all the restaurant to strings for each of the restaurants in the collection. So get that whole big string and print it out. So the calling program here gets to decide what to do with this string. Here we're just going to print it, but let the calling program, let the interface decide that, and let's let our model part, our collection part, do the more general thing. Okay, so this is going to take a list of restaurants, and it's going to return a string. Okay, so let's write the assert statements. Let's write the assert statements first. So if we have an empty collection and call collection to string on that, that should be the empty string. Right? It's generally good to check what happens in the empty case or the zero case, because we could have an empty collection, right? If the person starts the program and does P, says print the collection when there's nothing in the collection. We don't want the program to crash. It's got to do something. So that's good. We could say, let's see what else we have here. Let's have the collection with just R1, and that should be equal to restaurant to string R1. Now again, we might end up having an extra new line here, depending on how we do this. But no, actually, we probably shouldn't. It should be okay. And so we have a two element collection, and that should be. Let's see. I can just do it this way. Restaurant to string of R2 concatenated with R3. Okay, so I put these extra parentheses here so that I could continue on the next line without having a backslash at the end of the line. If you're within a set of parentheses or some other, paired delimiters like that, you can automatically go to the next line. If you're not, then you need to have a backslash to escape the new line. Okay, so empty collection should produce an empty string. Single element collection should produce the same thing that we get when we turn that into a string. Two element collection should produce the string representation of the first one stuck onto the string representation of the second one. So there are our assertions. Now let's write the code. Writing the code is not particularly hard. All we need to do, let's see where we are here, is this. And this is a pattern that we'll see often when we're building something up repetitively. We have a variable that contains the result we're eventually going to return. And then we go, for each restaurant in the collection, tack onto it restaurant to string of that restaurant. Okay? So start the result out empty for every restaurant we have, turn that into a string, stick it onto the result, assign it back to the result. So we're going to do that, restaurant, and then we should be done. Question in the back, yeah. Yes, so there's the shorthand assignment operator plus equals, which is the same. X get X equals X plus 1, X plus equals 1. So if you have the same thing on the left-hand side of the equal sign and the right-hand side of the equal sign, you use that shorthand. It's in the well, it does two things. Right? It saves you typing, but it also changes a little bit how Python handles things internally, an issue we will address. Good. Other comments or questions so far? So let's run this and see where we are. Add a restaurant. Okay, print out all the restaurants. There's the restaurant. Huh, not bad. Let's add another restaurant. There are the 2 restaurants. Okay? So we know how to turn a single restaurant into a string. We did that. We know how to turn a collection into a string by just taking the string representation of each restaurant, stacking it on. And then we know how to print them out by turning it into a string or printing the string, which we did from the handle commands program. All right? Comments or questions about this so far? Yeah. Okay, good question. So the question is, why do we have all of these collection functions here? Why don't I just say rc.append whatever here in this code and let it be done? Well, I'm trying to separate all the things we do to the list of restaurants from the things we do to a single restaurant from the main part of the program. And the reason is, again, to plan for possible future change, because we've chosen to represent this collection as a list of restaurants. But that's a choice that the main programmer, the programmer of the main thing, shouldn't have to know, right? I mean, I might decide to make it a dictionary instead of a list, right? A dictionary is another data structure. We haven't learned it yet, but we will. And the thing is, there's always multiple ways of representing something, and I, as the designer of my restaurant collection, might say I can make it more efficient or I can make it better if under the hood I change the way I represent restaurants. Well, for that to work and not to break the code that uses my restaurant collection, I have to have an interface, an API, right? An application programmer's interface. Just the way you have an API for all the predefined functions in Python, you know how the function works. You know the name of the function. You know what kinds of arguments you take. You know it takes. You know what result it produces, but you don't know how it's written. I mean, unless you go and look up the source code to Python, which you can do because it's open source. But normal people don't do that. They just use the function according to the specification. And so we've built that abstraction wall, right? We've built our collection all down here in this part of our program. And if we were to decide later to implement the collection not as a list but as something else, as long as the promises we make in our function definitions, right, what the name of the function is, what the types of the arguments are, what the types of the return values are, as long as we keep, and what the function does, right, as long as we keep that promise, we can change it under the hood all we want. And that kind of changeability, those kinds of firewalls of protection from the different objects and the code that we have to deal with them, they're essential when we start writing real-sized programs that are changing the world, so that you can limit the size or the scope of any changes that you have to make when you make the changes. So that's why we're doing it, right? We're building an abstraction wall, and we're giving the people who write the main part of the program up here, we're giving these people an API for dealing with the collection, and they never have to know that the collection is actually a list. They just have to know it's a collection, and we can call collection add and collection remove and collection search and collection whatever, and there we go. So that's the answer. Good. Other comments or questions? Okay, let's see what else we can do here. So we can print the collection. We can add. We can get an empty collection. The other things are not particularly hard. We can call search by name. Right, that takes a list of restaurants and a string, and it's going to return a list of restaurants. Okay, so this is going to be the name of the restaurant that we're looking for, and this is the list. And we're going to build up a list of all the restaurants in the collection whose name matches the string we're looking for. And that's basically the same pattern as before. Okay, so same pattern as I say. The result has to be a list. So let's start out the result being the empty list. And then we just want to go through and build up the list of matching names. Okay, so for each restaurant in the collection, if that restaurant's name matches what we're looking for, then take that restaurant and append it to the result. The result's going to be a new collection. We're going to return that result, and then we can call from the main program. Well, we have to do a couple of things. Make sure I've got it right here. Okay, so in handle commands for searching, where are we? Okay, so instead of this, we'll say okay, so ask the user for the name of the restaurant, and then say collection. Well, actually, there's no reason we can't just call. Okay, so take the current collection, take the name we just entered, call collection search by name, which gives us a collection, a list of the restaurants that match the name. So we take that collection and turn that into a string and print it. So that pretty much ought to do it. Let's see. Almost time to quit. Okay, so we have 3 restaurants, X, Y, and another X with some different values. And so if we search the collection for Y, there's the Y. If we search the collection for X, there are both X's. So I'm going to quit while I'm ahead.